Mommy, turn that down, please. Turn that down, girl.
Remember to mute your mics, all right? Remember to mute your mics. All right, let's go. It's 6 a.m., 6 p.m. So we're gonna start right about now. All right. All right, so we're starting. So here's the deal. I'm going through a number of questions. So I'm going through the few questions that came in first. And then we will just start going through many things that will be coming on the exam. Okay. And as you could see, we're trying our best to go through as many as possible because our exam is right there. So, all right, let us get into it. So here's the first question that we're looking at. It's a transformation question, right? It's a transformation question, and it reads, it says here that the diagram below shows triangle x prime, y prime, z prime, and x double prime. So you could see the double prime on these, y double prime, z double prime. All right, so they're here. We're looking at, so they're giving us information about these two triangles that we're actually looking at. All right, now from this, we're given a few questions, and the first one says here, triangle x prime, y prime, z prime is the image of XYZ. So this was not given. So this is the object. It was not given. All right. So we are told that this X prime, Y prime, Z prime is the image of. Okay. And this says after an enlargement of scale factor 2, and the center is 5, 1. So information that we got, this is going to be an enlargement. The scale factor is 2, and the center is 5, 1. Right. So that's information that we got. What are we going to do with the information? Basically, we're going to use it to respond to this. So the first question says here, and this is for 2 marks, it says draw triangle X, Y, Z. So they're asking us to draw the object. All right, so see here, the object for a triangle X prime, Y prime, Z prime on the grid. So on the grid, so I have my grid here, we want to draw the original thing, that thing that was there first. So our intention is to get X, Y, Z. And remember now, it's an enlargement with a scale factor of 2, and the center is 5, 0. So what we want to do is to identify 5, 1, identify the center right here. The center is 5, 1. So the center is right here. This is our center of the enlargement. So remember now, in order for you to get back this object, you're going to draw straight lines from the center to the vertices of the object, of the image, I should say. All right. So basically, we're going to draw this. So we're going to connect that like that. Somewhere on this, Z is, because whenever you draw lines from the center to the vertices of the image or the object, it normally connects corresponding vertices. Because the scale factor, I'm just going to say K, was 2. In other words, then we are knowing here that the original one was smaller because it doubled to turn into this. It doubled to turn into that, the scale factor of 2. So wherever it was, the distance doubled. So in other words, then you're going to have to flip. You're going to find a half of this distance. That's one way you could do it. There are multiple ways. A half of this distance right here will take you to back where Z was. So if you look at it, you're going to notice that a half of this distance is right here. Right here is a half of the distance. Half of the entire distance, this is where Z was. So in other words, then Z was here, and when it enlarged, the distance from the center doubled and reached here to Z prime. So we're going to do a second line. We're going to connect X prime right here. So you draw this, connecting here, X prime. All right, let me pull this up a little bit, right? And then you want to make sure that you're at the center. Just make sure that you're from the center so you don't miss, all right? So you just put it back there, right there, right? And then you look at that distance again. Because remember now we're going backwards, right? So, and I'm saying this is just one of the ways you could do it. You could see that this is half of the distance. So if I'm looking at X prime up here, then X would have been right here. This is where X was. And then when we use the scale factor, boom, it reached all the way up there. All right. And then you could see, let's draw the last one to connect Y prime. So we're moving from the center of the enlargement to Y prime right here. Right there. And as you could see again, the idea remains the same. Half of this distance, half of it, just look, half of it, you're going to realize that, hey, it's right here it's coming from. This was a Y. So all you're going to do now is to connect your X, Y, Z, and you're going to see a nicely shaped triangle, which was the original thing. So from time to time, they're going to do this to us. They're going to have us going backwards. I'm just going to try to let it look neat. So I'm going to probably put it in a different color, maybe blue. Put it in blue. All right, so boom. There we have that. Come down, right? That's that. And then the last line. And we could take a good look at it. You could see that it really was enlarged. Take a look. Look at both now. So just to confirm with you, if you look on two corresponding legs, like look at from X prime to Y prime, it's 2 units long, but the original one from X to Y here, it's 1 unit. So you could see that the scale factor would have doubled it. All right. And let's do one more check. You could check X prime to Z prime. Look along here. That was 1, 2, 3, 4 units long. Look where the original one was. It's 2 units long. So you could see everything doubled as you move from the object towards the image. So this is just one of the methods in terms of getting it out. Maybe one of the easiest one to look at the distance from the center, and based on what your scale factor is, you will scale it. Any question, guys? Quickly, any question regarding this? So we just did part 1, which was to drop the object. All right, we were given the image, so we dropped the object. Anybody with any question right about now? Going once, going
No,
twice?
sir.
No, sir.
Clear. All right, all right. Let us now look at the second question. So this is 2 marks, you know. Now the follow-up question here, says, hey, triangle X prime, Y prime, Z prime, right? Triangle X prime, Y prime, Z prime is, as you could see, it says, is mapped onto this one. These are double primes. Look right here, double primes, right? Double primes, right? By a reflection in the line P. State the equation of the mirror line P. All right. So if they ask you to state the equation of the mirror line, you're not going to do too much, right? You're going to observe. So let me go back to this screen where we could observe. All right. So we're looking at the 2 things. So let's take a look at it. We're looking at this and this right here. So they told us it's already a reflection, and you want to find what was the mirror. Where was the mirror line? The mirror line will be halfway between 2 corresponding vertices. So if, for example, let me highlight, let us say we have Y prime and Y double prime. Those are corresponding. You could find half of that distance. So I'm going to do a quick count for you. Let's count. Watch. 1, 2, 3, 4, 5, 6. So that's 6 units between them. This is telling me that the mirror would have been halfway, which is at 3, because you're going to share the distance of the image and the object from the mirror equally. So we're going to go halfway, which is at 3. So I'm going to go at 3. It simply means I'm going to stop at 1, 2, 3 right here. That's where my marker is. So I'm going at 3 right there. This is where the mirror is right here. And if you check other points, you could check this. You could check the Z's like this, and you'd realize that, hey, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means at number 5 units away, that's where the mirror would have been. Let's check from any one of the points. 1, 2, 3, 4, 5. You see, it ends up on the same line. So all you're going to do now is I'm just going to drop the line for you so you can see the line. Let's drop the line. This is the line right here. I might change the color to green or something. It's green. There it is. It's in green. That's the mirror line right there. And that line passes through 2 and the x-axis. So x is equal to 2. Now you're going to give them that answer based on what they asked for. They said the equation. So let us look. They said the equation of the mirror line. So that equation is x equal to. When we say equation, we definitely need to see a mirror. We need to see the equal sign between two ideas. Okay, so x is equal to 2 right there. X is equal to 2. So that was one of the questions that somebody was saying they had a little trouble with. So we put that out of the way. All right, let's go on to another one of those problems. Any question on this though, in terms of the mirror, to see it's half the distance between corresponding points from object to image? It's kind of straightforward for a reflection. This one came recently, I don't remember when, but when it came, a lot of people, kind of overthink it. It's not a big question, but I'm just going to show you what it is that I would want you to do. So I'm going to bring it to the better screen so that we could use lines to help us to navigate as we go forward. All right. So let me just put it over here. Not there. Let me put it here. So let me move this up a little bit right here. All right. So we brought it here. All right. Let it get a little bigger for clarity. All right. This is good. There it is. All right. Let's see what the question is about now. Let's go get it. All right. So it says the graph below, the graph below can be used. So this graph can be used to convert between United States dollar and Eastern Caribbean dollar. So you're seeing United States dollar on one axis and the EC dollar on the other axis, right? So it says use the graph. Whenever you're told to use the graph, you can't do certain calculations. You have to show that the graph is what helped you. That means you're going to draw lines on your graph to help you. So the first question says, use the graph to convert 2 US to EC dollar. So basically, you'll take your ruler, make sure you have a 12-inch ruler for your exam, long enough to just draw across. So 2 US to EC dollar. So you're going to identify where that 2 US is. You're definitely seeing that this is our 2 US right here, right? This is US. So what we're going to do then, we're going to take a line. We're just going to take a line and we're going to move it from here to here. I think I want to use red this time. Let me use red right here. All right. And you want to stop it right where it touches this. Right where at the moment it touches it, you're stopping right there. Okay. Boom. Now, you right there. So the moment it touches it, you stop. So right now it's looking like this is where I'm seeing it. So I blow it up a little bigger and then you're going to bring this down here. You're going to bring this down here. You're going to try to read off that, right? This is a little bit, I think the diagram was not done properly, was not 100% nice, but we could see where it is. So basically you could read off based on what we have. So if you notice here, so we're going to read off EC, whatever we get is going to be our answer. If we could look, it's a little bit dotted, but between these corresponding, these two, I'll say between these two spots here, between 5 and 6, that's 1 unit. You could definitely see that we're counting by 0.2. All right. So 0.2, 0.4, 0.6, 0.8. So 6. So we're talking about 5.2, 5.4. So I'm getting 5.4 right here for this one. All right. So this one is definitely 5.4. So you're just going to answer the question based on that. We're getting 5.4 when we read it off, which means it's $5.40. So let's go to the question. So based on my interpretation with the lines I drew, I'm getting that this will give me 5. Let me write it. It's going to let me write the EC. So we're getting Eastern Caribbean $5.40. That's what you're getting. Now, whatever you see, that's what you work with. I'm seeing 540 right now. So we work with our 540. All right, everybody, are we good with that? Is that okay? Is that okay? Is that okay? All right. All right.
Yes,
Let,
sir.
let's go to all right, all right, all right, all right, all right, all right, all right. All right. No, let's keep going. Now look at the second question, and this is the question that threw a lot of people off. The question says convert EC70 to US. You're going backwards now. But the reason why it threw people off was because, look, let me go back to the question. It says convert 70. Well, you're not seeing 70 because on the axis, you're not seeing 70. But I'm going to show you that the key thing about it is a straight line. Whenever you have a straight line, there is consistency in terms of the ratio between the two axes. Straight line is like the gradient remain the same. You understand? So you are able to scale down, scale up. So we are going to manipulate this idea on the graph. Take a look at how they would want you to do this. All right? Watch. Now, 70. 70 is what you're focusing on. So you're going to look at it and you're going to realize that there is no 70. Nevertheless, there is a relationship between 7 and 70. So we're going to take EC7 and we're going to find out what 7 is. And then I'm going to show you how you manipulate it. So we're going to work with 7 because 7, you could see 7 easily linked to 70 by multiplying by 10. So we're going to take 7. You want to go up on your axis like that, no biggie. Up on that 7 line, should say right here. Take it right there. Right? So you want to see right where it touches it, right there. And then you're going to bring this across. So we're going to take this all the way across over here. All right? Relax, take it across, no big deal. Take it across and blow it up, right? So we're seeing it there. We want to interpret that, right? So we want to interpret this, but it's the same. We have 2, we have 3. There is 5 equal spaces, so it's going up by 20 cents. So $2.20, $2.40, $2.60. This is a $2.60 line right here, $2.60. So we're going to take this $2.60 now. So 7 links to $2.60. You have to draw the lines for them whenever they say use the graph. Watch this now. So 7, now watch this. EC 7 gives us US $2.60. Therefore, EC, watch this now, 70. Because if I multiply all of this by 10, I just up the game from 7 to 70. Therefore, US $2.60 becomes $26. That's what they want to do. So they wanted to see that it's a straight line you had. We only can do that with a straight line. There is consistency with that straight line. So we're able to just take the 7, find it as 260, and then multiply by 10, and then you get what they actually wanted. Any question?
Sir,
Listening.
so what if you had figured it out and you didn't write the 7 and the 2.6 and you just went straight to the 70 and the
Yes.
26?
Yeah, man. But tell me what
That
you
would be
did.
okay.
Tell me what you did, because that is very important, because the question says using the graph. When they said using the graph, they're expecting to see lines moving on the graph. So yes, you could approach it other ways. I'm thinking this is one of the easiest ways, but we're not saying it is the only way. So I would love to hear what it is that you express. Go ahead. Let's hear what you did, and then I'll see if it's something that they'll work with based on their instruction, though. Because it was not just to get an answer. You know? It says using the graph. This is the issue. You got to be on this, right? So tell me what you did so we can see if it is okay, valid.
Sir, basically I did the same thing, but I'm saying
Mm-hmm.
if I got the concept that 70, because
Yes,
when we did the first one and you said it's 5.40, I was saying
yes.
that yes, it changed to, so the 70 would be equal to the 7. So I would still use the 7 line to get the answer,
Oh,
but
okay.
I'm
You're gonna
asking if we
be
have to write.
No, you just need to sort out yourself. As long as you're on the graph, you're good to go. All right? As long as you're on the graph to
Okay.
show what you did, you're good to go. There's never any one way to get these out. All right? So as long as you end up getting your thing, you're good. All right. Good to go. All right. Good comment. All right. Let's keep it moving, guys. Remember, you know, right now, if you're here, what you could do, you could take the link from my YouTube and share it right now. Just share the link. We're live now. You could share it to your status. Like you could just go there, copy the link, put it up there so more people can log on from elsewhere. All right, I made the video popular. Let's go. All right, so now we're going to jump on some questions now. So I'm going backwards tonight because most times we go from small and then by the time we reach the bigger questions, we're tired. And so tonight I'm saying, you know what? Why not go from top? Go from the back. So we're going to tackle the bigger questions. So I'm going all the way to the back of the paper and then I'm going to go from 10 to 9 to 8. I will tracking down. So we're going to get out some of the harder ones early when we're up and bouncing. All right. All right, so let's go. All right, so this one now, it's a vector matrices question. Vector matrices, let me see if I can minimize this. So on a vector matrices, this is a question that came that year. It says matrices A and B are such, so they give us A, they give us B. The question says, show by multiplication, by multiplying A and B, that AB is not equal to BA. All right, so whenever you're asked to show these things, you know, all you're going to do is do it. You're going to show. So by showing, it means you're going to have to execute this multiplication. So you're going to set up AB first. So this is the matrix A, which is 3, 2, 5, 4. This is the matrix B, and this is 4, 0, 3, -1. That's the matrix B. So what you want to do is you want to work this out, right? You want to work out your AB. Remember, we're multiplying this row by column. So here is row 1. Here is row 2. And then this is column 1. And this is column 2. Okay? So it's row by column. Row by column. So let's execute this. And then we see what we get. And then we compare with the other one because we're going to have to work the other one as well. So row by column, row 1 with column 1. So it's going to be 3 times 4 plus 2 times 3. So we just did row 1, column 1, all right? And then now we're going to go row 1, column 2. So it's going to be 3 times 0 plus 2 times -1, all right? So we have that. So that row 2, row 1, column 2. We could do this because it's going to end somewhere under here. And then we'll go next. We're going to go row 2, column 1. So it's going to be 5, 4. So 5 times 4 plus 4 times 3. Then 5 times 0 plus 4 times -1. Now let's put these together in terms of numbers. So we're scrolling up a little bit. So putting together these numbers, all right? 12, so I'm going to put the numbers here. This is 12 right here, plus 6. Over here, this is 0. This is a -2. Take a look. This is 20, plus 12, 0, -4. All right, so we could finalize it now. I'm going to put it beside it. 18, -2, 32, -4. All right, so there it is that we have this. This is AB, right? So this is the matrix AB. What we're going to have to do now, we need to find BA. We're going to do BA now, all right? Let me scroll down a little bit. So we're going to do the matrix BA. So BA, B comes first. So it's going to be 4, 0, 3, -1. We're looking at BA times A, and A is 3, 2, 5, 4. Right? So now we're multiplying B times A. Set it up right, then we execute properly, relax. So row by column, right? So it's going to be 4. So let me just mark my rows one more time. Let me just put this black. So that's going to be our row 1. That's going to be our row 2. This is going to be my column 1. That's going to be my column 2. All right. So there we go. So we're following. So it's going to be row 1, column 1. So 4 times 3 plus 0 times 5. All right. So 4 times 3 plus the row 1, column 1. Then we're going to go 4 times 2 plus 0 times 4. All right, so that's row 1, column 2. Now we're going underneath that. So in the second row, so it's going to be 3 times 3 plus -1 times 5. So 3 times 3, -1 times 5. And then lastly, it's going to be 3 times 2 plus -1 times 4. So we're underneath this, we have 12 plus 0, 8 plus 0. We have 9 minus 5. We have 6 minus 4. All together, 12, 8, 4, 2. All right, so 12, 8, 4, 2 is BA. Now you could see for yourself. Remember now, they asked us to show that they're not. So we're going to put it, we're going to say, look at this. I'm just saying, since 18 negative 2, 32 negative 4, it is not equal to this. You're seeing it's not equal to it. So we can conclude that, hey, therefore, AB is not equal to BA. That's all. Not a big deal. So the testing to see your matrices skills. Are you able to work your things out? Can you put it together easily without making any errors as you go forward? So that's what that question is about. You had to multiply your matrices and then put it together. You had to do that. You had to do that. Any question?
No, sir.
No, sir.
All right. Everybody understand what I'm going to write this up?
Sir, maybe
Yes,
true I
sir.
was writing.
Yes,
You
sir.
see, that's why sometimes
Yes.
I don't like to write me while you're teaching.
Yes.
I kind of was lose focus when you write up here. And you
Yes.
said reason why they are not equal. I was
Mhm.
writing, so I lose focus right there.
All right. You're talking at the end?
Yes.
All right. Are you referring to here?
Yes, sir. Because I was trying to do this and do this completely right here. But with
All
the
right, cool.
explanation you were giving right here says it's not equal. That's where I lose.
All right. Remember, the question is what I'm responding to. Here is a question. The question says that you need to show by multiplying that they're not equal. So we did our multiplication. We got one here.
Okay.
We got the other one here. So it's only natural for me to draw a conclusion that since I am noticing when I look that they're not equal, then I can conclude that it's not equal.
Okay, sir. Okay, sir.
Remember now that the question is what you're focusing on.
Okay, sir. Yes.
All right, very good, very good. All right, so that is just the first part. Let us get into the other part. So the other part, this says, can you find the inverse of A? Not a problem. So to find the inverse of A, what we need to do is to grab that A matrix. Where is it? So it's 3, 2, 5, 4. So I'm going to write it somewhere here. This is the A matrix. It's 3, 2, 5, 4. So I love to double check just to make sure. I'm going to scroll back. The A matrix, everybody looking at it, 3, 2, 5, 4. That's the A matrix. They want us to find the inverse of the A matrix. Remember the idea for the inverse of the matrix, all right? So I'm just going to rule this up. So what's the idea for the inverse? The inverse of the A matrix is found by having 1 over the determinant of A, and then you multiply this by the adjoint of A. All right, so that is how we do that. 1 over the determinant of A times adjoint of A. Hey, mute your mic, everybody. Please remember, I'm streaming. Everybody, just mute your mic. Ask questions is fine, but I don't want to hear the background unnecessarily, all right? Let's go. So here's the deal. This is what you're doing. So what you need to do is just to go and find your your determinant. So if you don't remember, let us say I have a matrix that says A, B, C, D, right? For that matrix, let us say we call this matrix A, all right? The determinant of this matrix A, so I'm going to write the determinant of the matrix A is to take the product of the main diagonal, which is A times D, minus the product of the other, which is non-leading, right, times B, C, right? So that is what you do. We're going to do that now to the A matrix. So let us find the determinant of the A matrix that we have right here. It's going to be, let's take it, 3 times 4, not a big deal, minus 5 times 2. So basically, that's 12 minus 10, and it's equal to 2. That is the determinant of the matrix. Now, to write the inverse, we're just going to flesh this out now. Right, let's go for it. The inverse is to put 1 over your determinant, 1 over 2, and then you're going to multiply that by the adjoint. Now, remember what the adjoint is. So let me go here. Let us say I have the matrix A, right? So I'm just writing this. I'm trying to explain as I go. A, B, C, D. Adjoint A, okay? The adjoint of A is to switch. We're going to put D and A. We're going to switch them. So we're switching D and A. So you're switching the elements on the main diagonal. And then you're going to change the sign of the elements on the other diagonal. So basically, I'm going to switch 4 and 3. 4 is going to come here. 3 comes here. So that's switching them. But I'm going to change the signs for 5 and 2. 2 is positive, it's negative. 5 is positive, it's going to be negative. Now, this is our inverse. In what a definition of the inverse is, we're looking at it. But what we want to do, though, is we're just going to multiply the half, that scalar value, inside that matrix. So basically, whenever that happens, because there's a 1 at the top all the time, then you're just going to have the 2 sliding underneath. So you're going to have 4 over 2, negative 2 over 2, negative 5 over 2, positive 3 over 2. This is what we have. And then we could finalize it by just breaking down what can. 4 divided by 2 is 2. Negative 2 divided by 2 is negative 1. And we're going, so this is just negative 5 over 2, and this is positive 3 over 2. This is our inverse of the matrix. Let me stop, and then you have a look at it and see how much you agree with what you're seeing. And if you have a question or two to ask, you definitely can ask. Let's go ahead, people.
Sure, good.
Good? All right, everybody seems all right. No questions there. Are you guys sure? All right. Are you sure the explanations are working? I'm not doing too much or too little. All right.
You're good, sir.
All right, good. All right, good, good, good. All right, wonderful class it is. All right, let us now jump onto this. It says, write down so watch this question now. What it says, write down the 2 by 2 matrix representing that. So write down. So you are not going to try to work out anything. Anybody knows what will be formed when this occurs? We spoke about this sometime in class. Whenever that occurs, whenever like a matrix is multiplied by its inverse, there is something unique that happens. Anybody want to just quickly say?
So it becomes an identity matrix?
Exactly. Very brilliant. Very brilliant. The identity matrix. Who is that? Who is sounding so brilliantly? Right? The identity.
0, 1, sir.
Ah, that. Yes, man. 1, 0, 0, 1. You see, so CXC have a way at times we just ask you, because you notice they said write down, not to prove it. Don't try to prove this now. They never ask. They say write it down. 1 mark, write it down. 1, 0, 0, 1. Our identity matrix. That is what they wanted at that time. All right. So the thing is, at different times, they ask for various stuff. All right. And as you go, you read and make sure you follow the instructions. So I hope everybody is good right there with that. Right. Let's go to the next question. For the next question, they said, hey, write the following pair of simultaneous equation as a matrix equation. You hear what they want it as? A matrix equation. All right. So we're going for it as as a matrix equation. Give me 1 minute there. Give me a minute there. All right. All right. 1 second in the meantime. I'm going to go and think. All right. Yeah, I'm good now. I'm posting something here. Work with me. All right. Are we done? Are we done? Are we done? All right. So it says, write the following pair of simultaneous equations in the matrix equation. Remember, the idea of the matrix equation is like you have A, X equal B, where A, X, and B are matrices. And so watch this now. The A matrix will be the coefficient of the X and the Y's. And they're going to take that shape, that same shape. So basically, you're going to have 3, 2, 5, 4. That's our matrix A. And then you're going to have your variables next. X, Y. And then the other two things, 5, 1. Boom. This is it. You're done. They said, write it. So all you're going to do is just to write it. Write what it is in terms of you representing the idea. And what I want you to do is not to, because you learn a lot. I could say that you learn a lot in the class from September. But here's the deal. Don't just do stuff. Read, then do what they ask. Because people did this and do more in the exam. You're not going to get anything for that. All right? So let's go. And notice 1 mark for that. So don't overshoot it. 1 mark. All right, let's go now. It says, watch this again. You're not solving it. They said, write the solution. Write the solution of your matrix equation above as a product of 2 matrices. So in other words, then they're testing to see if you really know what's going on. Remember, look at this matrix that we have. Do you notice that this is the A matrix 3, 2, 5, 4 that we just found the inverse of up top? 3, 2, 5, 4. We just found the inverse of this, remember, right? So we found the inverse of it. So if you so in other words, then let me just write. So let me explain what I'm going to do and then I write it. If we have A, X equal B, and we're going to write this, which is my variables, as a product of 2 matrices, this will be here, but I'm going to have to find the inverse of this and multiply it by the B, of which we have our inverse. So basically, what they're saying is set up your XY here. The inverse matrix, which is 2, -1, I think it's -5/2, +3/2. That's our A inverse. I'm just saying. And you put it beside your 1, 5, which is the B. So this is like X is equal to the inverse of A times B over there. And we're done for 2 marks right there. Let me just stop, look, and listen for anybody who's commenting, anything that you have to say. Anybody? Anybody? Are we good? All right, seem like we're good. Seem like we're good. Seem like we're good. All right, so it seems like we're good. Seem like we're good. All right, let's go, let's go, let's go. All right. So basically that's what they sent that year for matrices. Now we're going into the vectors, and vectors is one of the most feared topics, but you're going to realize that the little stuff that you learn, all you got to do is to use it. Most times, like when I run these, you're going to realize that we touch these questions because I would pull from CXC questions throughout the class whenever we're practicing. So 9 out of 10 times, we will do some of these questions already if I pick a random paper. But that's how it goes. It says the position vectors of the point P and Q relative to the origin are as follows. OP, which is 4, 3, and 0Q, which is 5, 0, respectively. All right. So here's a question. It says the diagram below shows PR. All right, so it shows that PR is equal to 3 OP. We're going to have to focus. This is PR, and we're told that it is 3 times OP. Look, this is OP right here. So we have to think of those when the right time comes, all right? Information given is so relevant to you going forward. QS is equal to 3 times OQ. So QS is equal to 3 times this piece right here. Not a problem. So we are taking note of this information because I strongly believe that sometime in the near future, we're going to have to come back to that to help us out. All right. Let us now just browse through to see exactly what it is that they want from us. The question says express in the form xy, all right, which means to put your components here, all right? The vector OS. Take a look at OS. They want from O to S. Well, here's the deal. If I want to move from O to S, all I need to do based on the information that they have. So I'm going to put on some labeling here. We did get OQ. So I'm going to put on OQ. It's 50. I'm going to put it right here for us to look at. OQ going that way is 50. And we were told here that QS is 3 times that. So that means I need to find QS. QS is equal to 3 times 50. So this is going to be 15, 0, because this is regular matrix multiplication by a scalar. 3 5s 15, 3 0 0. So what I'm suggesting is we have 15, 0 right here. And we're talking about from Q to S. So if they want OQ, take a look. OQ, I'm going to show you. We're not going to rush it. OS, my bad. OS is equal to moving from O to Q plus move from Q and go to S. Let's stop and look at it. We're talking about moving from O to Q, then move from Q to O to S. As I said, don't watch. Sometime my mouth slipped up. All right, so we're moving from O to Q and then Q to S. Now from O to Q is 50. We got that from them. We worked out QS, which is 15, 0. We're adding these because that is all we do in vectors. We add, we keep adding, and you're going to realize that you're going to get 20, 0. So this is OS. OS going in that direction. What's my arrow? Is 20, 0. Any question on that? Are we well okay with that question right there? Are we okay with what they wanted? How we put
Yes,
together?
Yes.
sir.
All right. All right.
Yes, sir.
So, all right. Sounding good. Sounding good. All right. I like that. All right. All right. All right. All right. So let's keep it going. Let's keep it going. Keep it going. So they want us to do PQ. So now you need to take a look. PQ. PQ. All right. So PQ is that we want to move from P to Q. So allow me to let me see if they have. Allow me to take this to the other screen? Give me a second. One moment, please. Let me just take right here. I could just take everything right here. All right. Let us bring it there so we could just work. All right. All right. So the question wants us to work out. So let me just put it. They say, hey, can you give us PQ right here? They want PQ. All right. So let me just drop our arrows on it right here. So you're moving from P to Q. The arrow is very important to whatever you're doing. You're moving from P to Q. You got to take into consideration stuff that you got. So we got OP. So I'm going to just put it up there. OP. So I'm just going to click back on the screen. We got OP. All right. So OP was 4-3. All right. So I'm going to put it here. OP was 4-3 going up. So we got this to be 4-3, but going in that direction. Right. Remember now that we are going from P to Q. So they ask us for PQ. If you're going from PQ, the best way is to move from P to O. Take a look at our direction, and then we move from O to Q. P to O, O to Q. this way. P to O, O to Q. And we would have moved from P and end up at Q. Now, when you move, arrows are so important in our vector world. Look at the arrow, right? We got P, let me just take this off. We got P, we got OP going up like this, but we have to come the other way, which means the components of this will switch. So we're gonna have to tell me, yes, Hilton, you wanna tell me what to write for this? Right here, go, you wanna go?
No, sir.
All right, so it's gonna be -4 and -3 because both of them signs would have changed because we
But
would
I
have come
said negative, but I guess I didn't hear.
Yeah, man. I just wanted you to talk on screen. All right. More interaction, you know? All right. So there it is. So there it is. So we change the direction of the OP because we're going PO. And then now it's regular addition of matrices. Remember? So let us add a -4 plus 1. -4 plus 5 is 1, should say. And -3 plus 0 is actually -3. And there it is. We have our PQ just like that. All right, any question relating to that? Any question relating to that? Let me see if there was any specific instruction here. Expressing the form, okay, just expressing that form. All right, we're good. All right, we're good. Wrong field. All right. So we have the PQ, we end up with getting 1, -3. That's what we got from this working right here. Well done. Anybody wants to ask anything, any
Sir,
uncertainty? Yes, go ahead. I'm listening to you. Speak.
sir, I knew it was negative, but I was saying it was -3 and -4.
Negative. Oh, okay. You probably never I think you're good. It's just that you never remember that they told us it's 4-3. So hold on. Let me see if I can understand. Is it that you were aware it was 4-3, but you think you need to flip it upside down? Is that what you did?
Yes, yes, sir.
All right. So let me just advise you. You're not going to flip them because what happened is you're changing your direction. So let us just look quickly. So 4-3. If 4-3 is to go this way, if it is a vector, 4-3 goes that way. If you're coming this way, what it means is that you're going against it. So there is a negative that affects everything. So it's everything will remain the same way, but their signs would have changed. So we would have ended up with a -4 at the top, -3 at the bottom. The sign changes, nothing else. There is no flipping of anything, only the sign would change. Are you good with that?
Yes, sir, thanks.
All right, good, good, good. Let us take a look at the other question, all right? So what did the other question say? The other question said, let us find RS, all right? Let's find RS. So I'm going to go to the screen where RS is. So we're going to look at RS right about now. In the meantime, let me take off these right here. We could put RS close to it. All right, let's put RS right here. RS. Put it right here. Now, let me drop a line for us for RS. So RS is coming from R going to S right here, right? So we're going that way with our RS and we put our arrow to show that we are at R, we are heading to S. R is the tail and S is the head, all right? So now we have our RS. Now we want you to take a look. Remember, vector is just a walk. The vector that they ask you to find, you don't have that. You don't have that. So you're creating a path with enough information to guide your walk. So in other words, then, we have no road here, okay? But we want to move from R to S. We're saying, guess what? We're going to travel from R to O, and then we pick up from O to S. Can everybody say, a triangle walk? So this is called the triangular law of vectors, where almost every movement that you see, you could put it in the form of a triangle, and you add your distances as you walk along the road. The only piece of information that is missing from us is right here, but they gave us a relationship, though. They had told us that they told us, let's take a look. They told us that PR, we were told that PR is equal to 3 times, yes, 3 times OP. Agree? Yes, we got
Yes,
that in the
sir.
beginning. So that means because I know what OP is, I could say 3 times 4, 3, and it's going to give us 12, 9. And that is, so I'm going to put it on the road, so you could see 12, 9 going that way, right there, right? So we'll put up our traffic. And then now we're going to walk because I'm going to walk from R to, take a look, you're walking from R to O, and then you move from O to S, and you reach, right? So it's all of these little pieces you're adding up. You understand? So basically, RO, you could just drop your RO quickly anywhere because your RO, and remember now, you're coming opposite to these, So we're gonna have to come in this way now. So I'm gonna put RO because we don't have RO. We could put it somewhere if we want, because see, don't really stress this, right? RO. RO is gonna have your -12, -9, plus your -4, -3, because the direction would have changed. Agree? The direction would have changed for that. All right. So we're talking about a -16 and a -12 because we come in the other direction. So 16, 12 would have gone up, but we're coming backwards. So it's -16, -12. So we need that -16 here, that -12 here. That's from R to O because we're coming against the original arrow that was given. Plus, everybody remember that this was what? 20, from what we
20.
all right. So now you put it together, you're going to get +4 with the -12 right here. So this is RS like that. So let me just sit and wait now. Let's wait.
Sir,
Question and answer time.
but the P
Go
and
ahead,
the
I'm
Q,
listening to you.
the P and the Q no be in it.
The P and the Q wouldn't, if it wouldn't be what? Go ahead.
Like you have from R to
What about P?
I think you'll have R to P.
Okay. All right. Let me help you. All right, let me help you. No, you don't have to. So yes, you can, but no, you don't have to, because we did it, Look, we add everything to get one thing for RO. You see it right here? So if you want to say, if you want to do that, it's up to you. But because it's a straight line, I didn't. I just add them and go RO. So yes, you could have said RPPO. Talk to me, because RPPO will give you, yeah, because it's going to give you the same thing. So what we did, we just took a second right here and add it, because this would have been your RP and this would have been your PO added to give from R to O. Talk to me now. Talk to me if you say that. All right.
Yes.
Good. Yeah, man. So yes, you are correct. And you do it in the exam, good to go, no issue. They have no problems with that. Any more questions?
No, sir.
No, sir.
Right. All right, let's go again. All right, let's go again. Let's see if there's anything else that they want us to do. All right, nicely they said, hey, state 2 geometrical relationship between PQ and RS. This is normally a nice little thing. So they want 2 geometric relationships. So guess what? I'm going to write back the things here. I'm going to write my PQ and my RS here. PQ. Let's look back what it is. Can't make any error. PQ is 1, -3. PQ was 1 with a -3. And then RS, we just did it. It was 4, -12. There it is. Now, whenever CXC give these questions, to be honest, it's kind of redundant. They ask this every year. Parallelism is going to come out. You're going to find some scalar multiplication. That means something multiplied to give something, or you can say a fraction, whatever. Anything, any number you can find. You're going to use that to give 2 relationships quickly. For example, so they said state 2 geometric relationship between PQ and RS. Let us look. You observe them. You take a look at this, you take a look at that. You run them through your brain and you said, what is going on? You look carefully. What is going on? What it is that I notice? And I'm going to tell you what to look for. Can I multiply one to get the other? Can I multiply by an integer? Can I multiply by a fraction? It doesn't matter. So in this case, Anytime love to use a fraction, but I'm going to use the integer. So you do notice that if you say 3 times PQ, I'm going to do it just for clarity. So we look at it. I'm saying 3. I should have said 4. I'm really saying 4, okay? So if you notice, if you said 4 times PQ, you're going to have 4 times 1 negative 3. Let's take a look what we'll get. You'll end up with 4 negative 12. What is this? It is RS. Talk to me.
Yes.
So you're noticing here that 4 times PQ does give RS. Because of this fact, we do notice that they're parallel, because whenever one vector is a scalar multiple of the other vector, they are parallel. So this is telling us that relationship 1, RS is parallel to PQ. That's one relationship. And it's always that, honestly. The second relationship that you could tell is, and we're talking about relationship, can you relate them? You could tell that one is a scalar multiple of the other, as well as you could speak of their size. So I'm going to just say this to you. So I'll probably write 3. So the second one that you could have written is to focus on their magnitude, because this tells how big one is to the other. In other words, 4 times the magnitudes, I'm using magnitude now, when I use my bar like that, 4 times the magnitude of PQ is going to give you the magnitude of RS. This is a language that speaks for itself. You write this, you're good. You're telling them that one vector is 4 times bigger than the other one in terms of its length. Another thing you could have said, I'm going to just drop it. You could have told them that we do notice that PQ or RS, you could say PQ or RS. Any one of them you want to pick on. Any one of them you could pick on. So you could say, all right, RS is a scalar multiple of PQ, and vice versa. Because we take something, we multiply by PQ, we get RS. And if I reverse it by taking a quarter off, because if you multiply by 1/4, you get the other one, So there are so many things we could do here, but we got to go in the interest of time. We're not going to write everything. But definitely, you only need to write 2 of these and you're good to go. I hope everybody's good right there.
Sir?
I'm listening. Go ahead.
Sir, okay. So if we write it's parallel and write that it's the scalar multiple, wouldn't that be the same thing? Would we still
Sure.
get the mark?
Yes. 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 It's just that you have a lot of knowledge. Your knowledge, because all right, parallel is a different thing. Parallel is parallel. You understand? So this is something you're telling them that they'll never meet. One is a scalar multiple of the other is another thing, but you use it to tell parallelism, but it's still another thing. It's 2 things that are ready for real. Yeah, man, it's 2 things that. But normally, I hardly use that one because this is what I normally use. I normally use the parallel and then I use the size and gone. I'm just giving you information here. All right. So normally I use these 2 and I'm gone. All right. All right, let's go again. Let's go again. I think that's a vector question. It's done. So we're done with that number 10. I'm gonna scroll up to number 9. I don't think there's nothing else. That's the end of the test for that. All right, because we're going backwards, right? We're going to number 9. Let's see what we have at number 9. Going up to number 9, everybody. All right, well, I'm gonna just drag this a little fast. Give me a minute. All right, so we're going, as I said to you, we're going backwards. So that's what it's going backwards. This one, no. So for you guys, all right, so we're going backwards. We are at number 9. So, all right, we are at circle theorem. All right. Right. So geometry and trigonometry with circle theorem normally comes right here. And it's always there, to be honest. It's always there. So we always have to look out for it and put it together and get going. Circle theorem. All right, let's go. So it says here, P, Q, R, S are 4 points on the circumference. So you see, they like to tell you straight up that, hey, there's 4 points on the circumference of the circle, and so on and so forth. So you're seeing the 4 points. They're telling you, all right? That means we have a cyclic quad already in the making, all right? But we don't know if we're going to use it, but we have a cyclic quad going on, right? And it says angle QRS is 58. So we got that angle already, all right? So let us see what it is that they want from us. Well, let's see what they want from us. I think I would want to put this diagram somewhere else so that we can go back and forth without missing out too much. Give me a second. Let me grab this diagram here. All right, so we are over here. How you guys feel as it relates to going into Friday? How you feel going into Friday?
Good, sir. Feel confident.
Stress out, sir.
You feel like you
Nervous.
see enough.
Just out there.
Yeah, man. Apart from the
Nervous.
nerves, in terms of awareness of content, how you feel. That's what I'm interested in terms of awareness of content, how you feel
Sure,
in
boy.
terms of what you see.
Sir,
Like,
me feel
feel-
better going in the exam coming Friday.
yeah, all right. No worry yourself. I remember we have class tomorrow and we'll probably drop something Thursday again. We'll do a lot of things. All right. First question this says,
Sir,
all right. I'm listening to you. Speak to me.
I found the answer for the question already.
Woo. Yeah, give me a minute. Let me read the question first, and then me ask you what you found. All right, let me read it first. It says, using the geometrical property of the circle, all right, to give reasons for each step. Ooh, they want each step. What about writing? All right, determine the measure of SPQ. SPQ. Normally, I will say SPQ, mark the angle. So I'm going to mark the angle SPQ, and then we're going to talk about it. SPQ. SPQ. Boom. Yes, I am. Talk to me now.
Yes, so the answer for the question is 122 degrees,
Yes.
sir, because the angle R is 58 degrees, so you subtract that from 180 degrees, sir, because the opposite angle in a cyclic quadrilateral inside of a circle, the opposite angle is equal 180
Very
degrees.
good. Very good. Very good. Very good. Very good. Yeah, man. Yeah, man. That's it. Couldn't said it better. So the reason is, as he's just said, I'm just going to write it. Opposite angles in a cyclic quadrilateral are, I'm going to use this word, supplementary, just for helping if you remember. But you know, have to remember it, you know. And I'm going to put in bracket beside it, add to 180 degrees. That's what supplementary means. You don't have to say supplementary in the exam. So just like what he says, opposite angles add to 180. So opposite angles in a cyclic quadrilateral are supplementary, which means they add to 180 degrees. Rightly said, that's it. You nailed it. We're talking about CXC. We're ready, man. We're ready for it. We're ready for it. Circuit theorem and everything, ready to go. All right, so that's the first one, and that's the reason for it. Well done, well done, well done. Opposite angles. And when we say opposite angles, for those who don't see the cyclic quad, this is the cyclic quad. It is in green now. I'm identifying that cyclic quad. Sorry for my thing that gone off tangent there. See there? See the cyclic quad here? That four-sided figure where the vertices are on the circumference of the circle. And then now when we say opposite angles, we're talking about these. Opposite. Or it could have been these two opposite angles, right? So that one, all we have to do is to take it from 180, just as it was explained. I don't want to say much. It was properly dealt with. Let's go on to the next question. Boom. All right. The next question now says we want to find the angle OQS. Relax. So when we say OQS now, we're talking about OQS. Mark the angle. Where is it? Oh, Lord. Give me a second. OQS. Everybody. OQS, right here. Right here. OQS.
Sir, but that
Everybody, so
looks
let me just highlight it again.
parallel.
No, nothing looks anything. We don't see parallelism. We're told parallelism, Hilton. We're told, and if you're never told, it's not parallel. If you don't see arrows showing it, don't do it. All right? It's a trick. All right. But what I could say to us if we don't see it is where O is the center. Because O is the center of the circle, let me just write this here for you, right? Just gonna write this. Oh, let me write this first. O angle OQS. Now I'm gonna just give some little notation. OS is equal to OQ in terms of distance. Both of them are what we call their radius to the circle. Everybody agree? Talk to me if we agree. They're both radius to the circle right there.
Yes, sir.
Yes,
Everybody?
sir.
Right. So they are radius to the circle, which make this an isosceles triangle then. Make sense? Isosceles triangle. This triangle that I just outlined right here is the isosceles triangle. No,
Sir,
if yes, I'm listening to you.
mistake. I should say isosceles, sorry.
Oh my, that's good. That's good. So
Sir,
because
my
it's an
brain not got
isosceles
too
triangle.
much.
Yeah, man, I want to. So because it's an isosceles triangle, if I can find this angle now at the center, of which there is a rule that links the angle at the circumference to the angle at the center. If I can find that angle, then I could use it now to just walk out. All right. So here's the deal. Here's the deal, though. Here's the deal right here. Remember, though, that the angle at the center, so we're walking, we're working as we go through, right? So let us find the angle S. Let's find SOQ first. SOQ. That's the angle at the center. So the angle at the center, SOQ, is going to equal to
The circumference
58. Yes.
160 and
What exactly that rule? So it's twice. So angle at the center is twice the angle at the circumference. So you double to come here. This is 116 here. But you're going to have to write the rule as they say for each step. That's what it is. So you say angle at the center is twice the angle formed at the circumference. There it is. Right?
sir, but Q would that be so I think so 64 would have leave and then you'd have just split it in a 2 and have 32
Divide it.
32.
Exactly. Yes, ma'am. So now leading to this now you're getting it now. Now me here at the maths. So OQS is when you're going to say, guess what? If I take this from 180, since the three angles will add to 180. So if I pluck this out of 180, I'm left with 64. 64 will be shared equally because these two angles are twins. They are twins. They are angles opposite to the sides that are twins. So they are twins as well. So if you divide this by 2, you're going to get that each of them will be 32 degrees apiece, which would have answered the question that we wanted anyway. We have more information, but we would have been getting what we want at the same time. Let me just pause for a moment. Pause for a moment right here. So we got that. And then we could say, I'm just going to say the isosceles triangle here. We utilize the isosceles triangle, yeah? And we utilize the total internal angle of a triangle, right? Right there. We use that to walk ourselves to the end just now. Talk to me if we're good. Talk to me.
Good, sir.
Good to go. All right. Well, good. Sounding great. We're sounding like we are going. All right, we're going. All right. So now let's look at the other question, if there's another question. All right. So let's go to this. Oh, it's done. So that's it for the circle theorem. We're going on to a trigonometry question right about now, right? So we're going on to trigs. Let's get it. All right, so for this trig question, it says here that, hey, a ship leaves port A and it sails 52. So I'm just going to put this on. It sails 52 kilometers to B on a bearing of 044. I'm going to put it. All right. The ship then changes course to sail to port C. So from B, it changes course and sail to port C, 72 kilometers away on a bearing of 105. Yeah, just like that. So I'm just putting these on as I go. All right. So it says on the diagram, not drawn to scale, the diagram below, not drawn to scale, label the known distances traveled and the angle. So I put them on already when I was reading. So I put them on. So most times if you read and put on, by you finish, sometimes you answer one question. So as you could see, we put on what we got right there. Anybody? Anybody, anything yet? Anybody, anything? Anybody, anything? Come on. Anybody, anything? Talk to me now, man. Are we good with that?
Yes, sir.
Good? All right, people. Please like and share the video right now. Just stop, like, share the video, and drop a comment. Yes. Yes, ma'am. Somebody said, sir, I'm listening attentively. Ready? Okay, I thought somebody was asking something. They didn't bother. All right, we're going to scroll then. All right. Now, the question went further. It says, determine the value of ABC. ABC. Now, let's take a look at it. ABC. I love to mark my angle. ABC. ABC is all of this angle right here. ABC. We're going to utilize a few things to get it. There are more than one ways to get it, to be honest. So we're going to do it one of the ways, okay? Now, if you look, if I extend this, if I just extend this, then we're looking at the fact that there's a 180 here from north to south, because this would have been the south. So what it means then, if that is 105 out of the 180, I am able to furnish a part of this, which is about 75 right here. And that 75 would have stopped right here, right there. That's 75 right there. The second thing I could look on is the fact that alternate angles are what we call Z angles, would be your best friend, or as well as co-interior. But you could see the Z angle now will jump out at you. Look at the Z angle jumping out. Let me minimize this. Look at the Z angle now jump out at you. See the Z angle here? See the Z angle right there? That's the Z angle right there. So because that is the Z angle, as you could see, that means this is 44 right here. Because the Z angles are always equal. So that's the 44 there. Now, when you combine the 44 and the 75, you have everything. Yes, ma'am. So 44 and the 75 combined, we have everything. So let us put it together. So then this angle here
Sir,
at A, B. Tell me what you get. Sound like you have it. Go.
it's 119, sir.
Very good. 44 plus 75, when added, it's going to give us 119 degrees. So what we want to do is to make sure that we drop it there so we understand that all of this angle is 119. I'm going to take off like this, and then I'm going to put 119 degrees here. Just so another thing I want you to embrace is labeling as you go. As you go, you want to label. And the reason for that is it gives you insight into the next question that will be coming. All right. And you're going to see as we go forward, questions that are coming, you will have more insight into it. Let me know if we're good. Everybody all right up to this point? Talk to me.
Yes, sir.
Talk to me. Talk to me. All right. Sound like we good. All right. Let's see what the other question says. So the other question says, so let me drop this here. Let me drop this right here. Who it is right here? Give me a minute, please. Give me a minute, everybody. All right, good now. We're good. Had a little issue just now, but we're good. We're good. I'm back. Are you there? Are you there? All right, good. Had a little noise issue. I hear some noise just now. I just had to clear it up. All right, let's get it going. Let's get it going. All right. So the question asks us to find AC. So AC is right here. So we could bounce. I'm gonna work my AC right here. We could talk about it. So AC, as you could see right here. If you're asked to find AC, now we're taking a look at AC. AC is this. And then remember, if you notice, you're seeing a triangle. You have everything in that corner. Everything in this corner, we have it. Whenever you have everything in one corner, for example, two sides and an angle, or what we'll call an angle between two sides, if you find that, you're good to go. And what do I mean? All I'm saying is because of that, right? Because of that, we're able to utilize the cosine rule. Because remember, when it's not a right triangle, it's sine or cosine. And right now, cosine is what we're going to employ to help us to walk through because we have angle between two known sides. So the cosine rule states that AC squared is equal to 52 squared plus 72 squared minus 2 times 52 times 72 times the cosine of the angle that is between them. All right. So there it is that we have that. So we want to make sure that we have that down. Let us now just go through with our values. Take the calculators out, roll with me. So 52 square is going to give us about 2,704. Work with me. 72 square will give us some 5,184. And then normally when you reach this part, you're not going to subtract 2. You're going to put this on your, so clear your calculators, and then you're going to put all of this on the calculator at once. You're going to clear your calculator, and then you're going to put all of that on your calculator at once. So what am I talking? I'm referring to -2. Clear your calculator. -2 times 52 times 72 times cosine of 119. Also, make sure that your calculator is actually in degree mode. And you're going to get a positive number here.
Yes, sir.
3, you should get a positive 36. Confirm with me. You should get positive 3630.25. We should get these numbers up. So all we're going to do now is to add them up. AC squared is equal to, let's put them together, 2,704 plus 5,184 plus 3630.25. And this is equal to 11,518.25. So then you have to take the square root of both sides to find your AC. Square root of this, and we're looking at 107, right? 0.32. But let us say if there is a special instruction, because normally if we get special instruction, we have to take it. Let me just swing and look. It says to the nearest kilogram, to the nearest kilometer. So to the nearest kilometer, it means then to the nearest whole number. That's what they're referring to, a whole number. So it's going to be 107 kilometers. So what I normally do as well is to tag it onto my diagram. This is 107 km, and it's going to give me insights as I go forward to do another question. I'm going to pause there for a minute just for anybody to say anything. Let me hear what you have to say about this. Are you good? Is it clear? And let's see what's going on.
Yes, sir, it's clear.
So good.
All right. All right, let's go. Let's go. All right. It's sounding like we are all right. You do notice that every time you do variance, it's kind of, it's very repetitive. We're repeating the same ideas. We're going to use cosine rule, we're going to use sine rule, we're going to do this, SOHCAHTOA, the same things. All right. Let's see what the next question holds for us. So this, we found this to be 107, right? All right, let's keep going. It says a show. So we're going to show something. Show that the variant of A from C is to the nearest degree, important, is 206. All right, let us look on the idea. Let us talk about it first. Now, again, make sure that you have it down. The bearing of A from, very important, from. This is where you're starting. Start at C, and then you want to go to A. So we're going to go on our diagram, right? We're going to go on our diagram, and we're starting at C, and we're going to A. Remember, all bearings are from the north. So we're going to go to the north of C, and then we're going to go clockwise until it touches a line that lead to A. It's a bearing of A, but from C. So that's what we're doing right there. So I'm going to put it in a different color now. I'm going to just weave it in a blue. This is what we are trying to find. This, right? Now, watch this now. I'm going to come, there are multiple ways to approach a problem like this, right? There are a few ways we could approach a problem like this, but take a look. You want to look, you're going to see this. If I do this, I'm getting a full circle right there. My purple, not my purple, my blue and my pink together give me a full circle. If I could find the pink part, if I could find this angle in pink, all of this, and subtract it from 360, then I will have the blue part, which is the bearing that I want. All right, so we want to have that down in our thought process. Now we could start getting things out by look at this now. I'm gonna show you the Z angle again. It's your best friend, or you could use co-interior as well.
75, sir.
It's very good, very good. So this is gonna be 75 right here. This is 75. So if you want to use co-interior, where they had to give 180, or you're using Z angle where the 75 there is a 75 there. But the one thing that is missing from the pi is we need this right here. And if you add that to the 75 and pluck it out of the 360, you get the bearing that you want. So then we're going to have to now find that angle in the triangle. Now take a look at this though. Take a look at this. We're talking about the angle that we want, we have the opposite side for it, which is 52. We actually have 190 degrees, and we have the opposite side for that. So we can now utilize the sine rule that speaks to A over sine A equal to B over sine B. We can utilize that to help us as we go forward. In other words, what am I saying? I could take 107 divided that by the sine of 119, and it's going to equal to 52 on top of the sine of the angle. I'm just going to call it theta that I want. This is equal to 52 divided by the sine of the angle that I want in the triangle. And from here, we don't want to overstress, cross multiply. In other words, we could simply take this, cross multiply there, take this one, cross multiply, set it up, let them be equal, and move forward. So let's go. So 107, the sine of the angle that I don't know, is equal to 52 times the sine of 119. No, we want to isolate this, right? Which means at this moment, I am going to divide by 107, balance the equation by dividing by 107. You're seeing that on the left side, 107 cancel. So you have sine of theta is going to equal to some number here. Let us put those on. Make sure that you relax when you're doing this. So you could put this on. So 52 sine 119. Press equal, then you divide. So you want to equalize that first, then divide by 107. So I'm getting this. I'm getting this out. Make sure that you have it out. Let's go again. Everybody, check what you get. 52 sine 119. Confirm with me what you get.
0.425.
0.425. All right, so that means we're going to go sine inverse.
Inverse.
0.425. So this is going to give inverse that, because when you're going towards the angle, you have to use your sine inverse. You're going to notice that this is going to give us an angle of 25.2. All right, so we have 25.2. Double check with me if you get 25.2 right there. Just double check if you get that.
Yes, sir.
25.15, but we round up to 0.2. Now, let's go back to the diagram now with this. All right, you know what? Let me wait first and let's everybody digest this. And we see we're going to put it together now. We're going to put it together now. Let me draw a line here. Talk to me. Are we good? We good?
Yes,
Yes,
sir.
sir.
All right, good.
Yes, sir.
So we're going to put the 25.2 where it belongs. So let me clear back up this diagram for us now. Let's clear back up this diagram. All right. Now the 25.2 was right here. Right here. Now this is what I'm saying now. If I add that 25.2 with the 75, take it from 360, we get the part, which is the bearing. Right? So now I'm gonna write the idea that the bearing, allow me to write now. So I'm gonna write that, just writing that the bearing of A from C is going to equal to taking 360 and you're going to subtract 75 plus 25.2. So that's 360 subtract, what's that? We're getting some 100.2 here. So if you subtract the 360, we get 259.8. But they said to the nearest degree. So that means this is going to round off to approximately 260 degrees, which is the point that they want us to make right there. Talk to me.
That's right, sir.
Yes, sir.
That's to the nearest degree.
Yes, sir.
Anybody with any question pertaining to that? Any question? Any clarity needed? Or we think we're good?
Good, sir.
All right. I'm responding to somebody online. All right. All right, let's go to the next question. It's done. It is it. We're done. We're done. All right, so we're going to, I'm going backwards. So I'm going to go to question 1 now. I'm going all the way to question 8. All right. I'm going to 8. Talk to me if you're all right. When you're tired, then talk to me. Question 8, you will see, you will encounter some stuff that you haven't met yet. We're going to do that tomorrow. But definitely we can start talking about it from no, this is it. This is it. Or there's something else up top. Hold on. I think this is where it starts. All right. All right. Right here start. All right. So it's always algebra, relation, and function and graph for this section. In the graph section, they could send this for graph, you see? So they can send this for graph, they can send coordinate geometry, they can send any graph there, please, because it is titled algebra, function, relation, and graph. So they could send any algebra thing that is very difficult. They can send f of x and so on, quadratic curves and so on, anything like those. I did a presentation on these. If you check out my TikTok or my YouTube, you're going to see I start telling people what to expect at various questions. When I did this is the longest one. They have most option for this. But anyways, this one is a velocity against time. Velocity is like speed, except velocity is going in a particular direction and speed don't have a direction. So just a quick review. When you hear they talking about hurricane, it's the velocity they give because they normally tell you where it's going. Like they said, it's coming at 150 miles per hour towards Jamaica or towards Florida. They're telling you where it's going. So with it's a vector quantity because it has size and direction. So we're talking about the same arrow where you put by a vector. It come with this, but you're not doing vectors. I'm just saying it's a vector quantity, right? So velocity can be used interchangeably with speed. They are not the same thing, but it's the same application. So it's like velocity is speed with a direction, and speed is velocity without any direction. That's what we're saying. All right. So basically, no, this is a speed time graph. So I'm just gonna solve it, guys. You will learn about it tomorrow. All right. So it says here, the velocity time graph below shows the motion of a cyclist over 40 seconds. Right. So you're seeing the motion of the cyclist over 40 seconds. You're seeing the velocity here, and you could, as I said, you think of speed, and you see the time going. Now it says calculate the gradient of OA. Now, even if you have no clue about velocity and so on, you can at this moment.
So it's like the gradient.
Find gradient. Yeah, man. That's what I'm saying. I'm just saying to you, even if you never see the topic, you can find the gradient now because you learn how to find the gradient of a straight line in coordinate geometry. I'm saying to you, you could pick up this 0, 0 here. Tell me if you see that. Talk to me now. And you see 25, you see 25, 10 up here, so not true, as in the point A. So what I'm saying is, all right, at O we have 0, 0.
0, 0, right? Because 0, 0 there.
And at A, remember? Yes, it is. So now all you're going to do is to label x1, y1, x2, y2. You see the transfer of knowledge where you learn, just keep doing it.
Sir, so you would use the V, like V1 and the time. You don't have to use it that way?
You can if you want, but they don't care.
Okay.
Yeah, right. Very good. You can if you want. The reason why I'm picking up the coordinates here for you is because is basically that's how you learn gradient. So I'm still letting you see that connection that, hey, I'm not on a strange ground. So I'm not even going to use any V1 because CXC now mark for the formula. They're marking for the concept. So let it stay within your world. So in that world now, we can say, remember now, say gradient, yeah? Gradient is equal to y2 minus y1 over x2 minus x1, which is in context here, y2, 10 minus 0 over 25 minus 0. What are you looking at? You're definitely looking at 10 over 25. And if you break down this 10 over 25 now, right? By dividing through it by 5, so 5 into this is 2, 5 into this is 5. The answer that you're looking for is actually 2/5, right? That's your gradient, 2/5. There you go. So that's your gradient of OA. So that straight line OA, when you picked up your thing, you work it out, you're going to get 2/5. Talk to me. Come to me. Let's let me know
One
if you're all right.
moment, sir.
Yeah, man, I'm listening. You want to ask a specific question? Or are you good?
No, I just want to write off this quickly. Then go soon.
Okay. All right, we good? All right. Make we go on again. So we find that. You notice a 1 mark feet, not a big deal, because they must say you know coordinate geometry. No, AB, we still see 1 mark again. AB, they want the gradient. AB, AB, look at AB. We still and you see, because them say calculate, you see when they use terms, me play with it. You notice them say calculate, so me I make the effort to show the calculation. AB is right here. We have the point A already, you know. So the point B is 40, 10. Everybody agree that B is 40, 10? Talk to me. Everybody could see B is 40
Yes,
means
sir.
10. 40, 10. All right, good. So let's go here. We're going to write our A. A is 25, 10. And B is 40, 10. Right? So we have that. So what they're asking us to do now is to find the gradient AB. Label up same way, man. Them say calculate x1, y1, x2, y2. We're still approaching it still. So what we're talking about now, that this gradient that we're dealing with right here is going to equal to taking y2 minus y1, put it over x2 minus x1. Do your substitution. y2, 10, minus y1, 10, over x2, 40, minus x1, 25. What we have here? 0 over what? Is that 50? Is that negative? Is 15? 15, which is equal to 0. Now, can you see that the gradient is 0? And I'm going to show you that the gradient was 0, but they asked it to show. Well, they didn't say show, but I'm saying they said calculate it. The gradient is 0. You know why the gradient was 0? By default, it was an horizontal line. A gradient is a slope. So a gradient normally go this way, this way. So it's positive when you're going up, it's negative when it's coming down. But it's when it's flat, it's neither positive nor negative because it is 0. So horizontal line when there is no slant. So we knew it was a 0 already, but the question wanted us to calculate this. You understand? So when you do your calculation, we see we get our 0 right there. Any question pertaining to this? Are we good with this? Any additional knowledge you want? If not, I'm going to keep scrolling.
No, sir, we're good.
All right. Don't worry yourself. I'm going to say we'll learn about this tomorrow. Proper thing. And lock down the syllabus. All right. Now it says complete the statement here. So what I'm going to do is to take the diagram to the other screen so we could look at it. We could talk about them. So I'm going to put the diagram over there and then we talk about it. Anybody will do physics, would I just find this simple? Because this comes in, if a GCSE physics you're doing or CXE physics, it comes in it. Comes in it. You understand? Comes in that part of the syllabus for physics. All right. Now, they're going to ask us to describe, or we're going to complete a table by looking at what took place here. Remember now, the slope, I'm going to put it on here. The slope was 2/5. What it means, you know, you're going up 2 by going across. You're going up 2 by, all right. For every 2, your velocity go up. 5-second pass, or something like that, it's a say. Right? Rise over run. Rise over run. So it has a something like that. 2 to 5, right? So you go up 2 5-second pass. That's what it is saying. Or another 2 5-second pass, or next 2 5-second pass. That's interpretation. And we realize that this is 0 here again. Yeah, because we were not elevating anymore. So let us now see if we could complete what they wanted, right? So let's go to the question. Let me see if we can blow it up a little bigger. Here it is. It says, complete the statement. It says, the cyclist started from rest. Rest means, when you start from rest, you were not moving. So whenever you start from rest, you were not moving, all right? So if it says to you, start from rest, and look at this, where the velocity was what? If you start from rest, your velocity is 0. You start from rest. I'm going to show you on the diagram where the velocity, see the velocity here, so what was it from rest? This is rest. That is what we mean by you start from rest. Beginning, you were at 0. The velocity was 0, even time was 0, all right? So start from rest, the velocity was 0 meters per second. And steadily increase his velocity by what? So steadily increase the velocity. Make a look on the graph. You're increasing your velocity by this gradient, man. 2/5. Every 5 seconds, we go up 2. We increase. So if we were at 12, all right, let me go real. 0, 5 seconds with a 2 meters per second. Another 5 more second, 4 meters per second. Another 8 meters, and it keep going. So it increases steadily with a velocity of 2/5 meters per second for each second during the first 25 seconds. Look, during the first 25 seconds. See there? The first 25 seconds, which is the straight line where them ask if you play with. That straight line that them ask if you play with. See there? Boom, right? 25 seconds. After that, now you realize that we are right here. This is A, we go to B, but we never increase our speed. Let us see what else they're asking. During the next 15, which was the A to B, which was 0 gradient, its velocity remained constant. The velocity would remain constant because you're not increasing or decreasing in your speed. You're maintaining. It's like you're up on the highway and you're at 80 and you're just a cruise now. All right? That is, its acceleration was 0. You were not accelerating because you were not going faster or even slowing down. So then you are at 0 meters per second square. That's 3 marks right there. A nice 3 marks. You're going to learn soon. Don't worry yourself. All right? We got to go. It says, during the average, no, it says, determine the average speed of the cyclist over 40 seconds. Now, what is average speed? This is regular life now. Speed, if you think of speed, you think of kilometers per hour, and meters per second. Meters per second. So a distance are linked with time. You're like, think about the unit for speed, and you realize you actually know the formula to find it. So if we're going to go average speed, it's basically total distance over total time. This is just regular day-to-day life. The only thing is now, when you're dealing with a velocity or a speed time graph, distance has to be calculated a certain way. So with this, I'm going to tell you how you find distance with these. Distance, so you can make a note of this, but you will learn it tomorrow. Distance is equal to, and we're talking about distance with a velocity graph. We're not saying distance for anything. We're talking this particular graph, whenever it's velocity or speed against time. Your distance is the area of the plane shape seen. And I'm going to say the right term to say it's area on the curve. When them say curve, they mean area under your graph. Area under your graph. And me, I said to you, the plane shape that you can identify, if you can find the area of that plane shape that you're seeing for that time elapse, then you automatically find a number that is equivalent to the distance traveled. The area of the shape is equivalent to the distance traveled. That's what they discovered years ago. Like people do it and say, oh, it worked. No, let's take a look. What shape
Sir,
are we
can I
seeing
go back
here?
down 1 second?
You want me to go back to this screen right here, sir?
Yes, sir.
Talk to me when you want me to move.
No, I'm finishing writing it.
So what I said, drive up. All right, so may I drive? All right, so here's the idea now. Area under the curve. So what type of shape is this, everybody? Come on, man. Look, see the shape here? What kind of shape is this? See there?
Trapezium.
Exactly. This is a trapezoid. Now, if you don't want to find the trapezium, you can split a trapezium in our rectangle. And what? Look again. What are you seeing now? Rectangle and triangle. Exactly. But you see, with me, I'm not gonna do that. I'm gonna just say, look here, we know a trapezium and then gate. So now let's look on the sides now. Come on. In terms of distances, right? This is 40 down here already. You see 40? Yeah? 40. And this part up here is 25 to 40. So that means this is 15. Talk to me, people. This is 15. The one down here is 40 and the height 10. Tell me if we see that. I'm wait for everybody to confirm. The height is 10. Everybody see that?
Yes, sir.
Yes, man. So basically, we have a shape that looks like this. Yeah? These are the parallel sides. This is 40. This is 15. This is at right angle. So this is the height 10. That's what we're finding the area of. So when we find the area of that, we get the distance that we need to use to work out the average speed. Let's go work it out. Now, let me put it right here. So I crash the diagram here so we can see it quickly. This was 15. This is 40. And this is 10. The area of the trapezium. So I'm going to write area of trapezoid. The area of the trapezoid is equal to, let me not write so many equal signs. It's basically equal to half the sum of the parallel sides times the height. That's it. So I'm working out the distance first before we go back to the formula. So this is half what? Is this 55? All right. So find out 55 divided by 2. Let me just drop it. 55 divided by 2, people. This is 55 divided by 2, then times it by 10. Somebody tell me what that is now. All right, 55, so 40. Let's go. Man, we pound if you tell me, it's not like me don't know what the need fee. All right. What we get? 275. So this is 275. All right. This is 275. That's the area. This is equivalent to your distance, total distance traveled. Everybody just confirm with me if we don't get.
Yes, sir. That's right. That's right.
All right. All right. Very good. So 275 meters. Now we're going to finalize the math now. This average speed that they're referring to now is basically equal to, you want me to write it up here? Or you want me to rewrite it down here? So you want me to just put it down at the bottom here, right? You could do it right here. Put it right here, sir?
Yeah, good, sir.
All right, good. So the average speed is equal to, I'm just going to write, I'm not going to rewrite the formula now because we did already. So I'm just going to put the things in perspective now. The distance, which is 275, divided by the time, which was 40 seconds. Whatever you get is the answer. 275 divided by 40 is going to give us about 6.875 meters per second. Meters per second. Average speed, you know, it's traveling at that meter for every second. Done. This is just an idea, people. Talk to me if we're good. So some people might think it's physics. Yes, it's a physics question that's a part of your math syllabus. And it does come at number 8 whenever it's coming. All right? Listening to you?
So I still don't know how you got the 15.
Yeah, man, no problem. And I'm going to show you. Oh, I got the 15. The 15. Look.
Yes, sir.
Yeah, man. We're talking about the parallel sides. So I'm going to highlight parallel sides for you. Come again. I'm going to put it in a rose pink or a pink, right? So that side parallel to this one. Agree? Talk to me now. So
yes, sir.
This one down here is 40. That down here is 40 because you can see 40, right? But how we got 15? Look, A is at 25 marker. See 25 here. And B ends at 40. So it's your responsibility now to say 40 minus 25. And it's going to tell you the distance, 15. Tell me if you're good.
Oh, yes, sir. Yes, sir. Okay.
All right. So we tie it up there. So we knock it up. Look at the question done though. Look like something else now. So basically, when you're learning, you're going to realize, man, don't worry yourself. This is it. Now I get no harder than that. You just need to learn some more things, and 1-2 hour session, now we're good. All right, let's go to the next question. So we're still at number 8. So they give speed velocity, but they can also now throw in algebra. It says consider the following pair of simultaneous equation. Whenever you get simultaneous equation at number 8, it's going to be the one with 4 answers, like 2 pairs of answers. It's going to turn into quadratic. X squared plus 2xy equal 5. That's one. The second one, x plus y equal 3. It says without solving, it says, look at this here. It says without solving, show that 1, 2 is a solution for the pair of simultaneous equation. In other words, this is one of the solution. There are 2. This is one of them. Show that it is. Now, how we are going to show is that the math must prove itself to be true. Because when you find a solution, you're actually telling us that this is x, this is y. And if you substitute them in these, notice I said these for plural, then it should hold true for both cases. For example, we're going to take this. We're going to substitute, watch. We're going to substitute x equal 1, y equal 2 in both. First situation, x squared plus 2xy equal 5. We're going to substitute x and y, and it should equal 5. If when you substitute x and y, you get 5, that means it's wrong. But if it is, then you are going there. X is 1, so 1 squared plus 2 times x, x is 1, times y, y is 2. It should equal to 5. We could go again. When you square number 1, you get 1. 2 times 1 is 2 times 2 again, you get 4. Think about it. 5 is equal to 5. Everybody see this sure say, yeah, the number is right because 5 equal to 5. Are you there? Talk to me now.
Yes, yes, sir.
All right. So, but remember now, somebody speak again. I think somebody said something. The last one. All right. Good. So this is, but you can't use it on one. You have to use it on both. So the second case now, you're going to have to try if x plus y give 3. Look again. X is 1. Y is 2. Equal 3. 3 equal 3. And you're like, yes. This is what they want you to do here. Because you're suggesting that when you substitute the so-called solution, it is proving the equations to be correct. Are we there?
Yes, sir.
Are you there with me?
Yes,
all right.
sir.
All right, very good,
Yes,
very good. That's it. That's it. This is maths, you don't get no harder, but you don't really get no easier. All right. Now, look at this now. It says solve the pair of simultaneous equation above to determine the other solution. So now we want to solve to find the other solution. Allow me to take this down here. Allow me to write this down here. Let me write them there. We have x squared plus 2. Let me write my x like this. This is equal to 5. And then x plus y is equal to 3. Let me make sure that's what we have. Make sure we have it right. Very good. Now, we want to find the other solution, which means now we're going to have to solve. In other words, then, I'm going to substitute right now. I'm going to write x in terms of y, and then I'm going to substitute because remember, now is the substitution method you're going to have to use. So you're going to have to write x in terms of y or y in terms of x. So I'm going to write x in terms of y because I want to find the x. So we are suggesting that y is equal to 3. Bring this across or subtract it from both sides. You have minus x. Tell me if we're good with that. Write this up. So we're creating the third equation because this is equation 1. This is equation 2. We're creating a third equation so that we can use it to solve the problem. So we utilize equation 2 to create equation 3. Everybody remember when we did do them thing here? Just like this. So now that we have something for y isolated, I can take the expression for y and put it right here so to start solve a problem. So watch this now. We're going to substitute. Remember now we have x squared plus 2xy, which is equal to 5. This is equation 1. Let me talk to you. Because we use equation 2 to create equation 3, we have to substitute in the other equation that we did not use. So we're going to substitute in equation 1. All right? So we're going to substitute in equation 1. So equation 1 is x squared plus 2xy equal 5. But remember now, y is something else. So watch this now. X squared plus 2x, y is 3 minus x. Come on, people. And this is equal to 5. Let me stop there for a minute. Make sure everybody see that. You cannot solve an equation with two different unknowns. So because we have two unknowns, we had to get rid of one and then we move. So in this case now, it's our responsibility to use our algebraic skills as we go forward. For example, x squared, then I'm going to distribute the 2x inside. Come on. So 2x times 3 will give me 6x. 2x times negative x will give me negative 2x. Are we there? With a square on it now, right? And then this is equal to 5. Let us stop, look, and listen. Are we good up to that point, people? Waiting on some form of confirmation of truth. Waiting. Talk to me. Are we good?
Yes, sir.
All right. So now let's keep going. So now you're going to solve because it's a quadratic, you're going to amalgamate everything on one side, man. So we're going to shift everybody to one side. So this 5 will have to come over here to mix up with everything so that there is a 0 hanging by itself. While we're organizing ourselves, remember the deal. Or if you don't want to work with a negative x squared, you can bring everything on like this. Suppose you don't want to work with a negative x squared. You can bring everything to the other side if you want and left the 0. So let us do that because most times we don't want to work with the x squared negative, most times. So watch this now. Take a look. Take a look at everything that we got right here. All right. So it's up to us still, it don't matter. It don't matter to me now. Maybe let's do it now first and then we relax. We'll have a negative x squared here, a positive 6x, and this is equal to 5. I'm suggesting that if you don't want to work with the negative x squared, bring everything on the other side. So watch this now. If you're bringing everything on the other side, right, then you'll have a positive x squared over there. This will be a negative 6x over there. This is already over there. You're not moving that, so it's going to be a positive 5. And the other thing is 0 by itself. It doesn't matter if the 0 is to the left. It doesn't matter if the 0 is to the right. The bottom line is you're going to have x squared minus 6x plus 5. All right? And it's not wrong or right to go either way. I'm just saying if you don't want to work with that negative x squared, bring it to the other side so it becomes positive x squared. The 6x will become negative over there, and that's fine. Now, can you factorize this? Definitely we can factorize. We can. So whenever I can factorize, what I do is whenever I can factorize, I'm not going to take the long road, all right? Because definitely the factors A, I'm just doing it quickly for you. I'm still doing it timely. A is 1. B is negative 6. C is 5. AC is equal to 1 times 5, which is 5. All right? So here's the deal now. Here's the deal. It's only 1 and 5 you have to work with. AC is positive. So that means you need either two positive or two negative. But because your b is negative, you have to use -1 and -5. Because remember now, -1 times -5 gives +5. -1 plus -5 give -6. So you could see that it multiplied to give you your AC, but when you add it, you get back your B. So we're going to use -1, -5. And remember where it's going to go. It's going to take this place right here. It's going to take the place of the -6. So watch this. X squared minus 1x, but I'm just going to call it x, minus 5x plus 5 equal 0. So basically, you know, that's me. Now, when you have 4 terms, you have to group them. And remember, everything tie up back, you know. Group 1, group 2, you group them. So in factorizing this first term here, first set or first pair, you'll take out x. So x, let me just give myself space. I'm showing you everything that I skip. You'll divide this by this x, then you divide that, right? So you're going to have x minus 1. And then for the other two, you'll take -5. So you divide this by -5 and divide this by -5. Now you'll get x minus 1 equals 0.
Excuse me, sir. Which year past paper is this?
It may be 2017, January or May. I remember, May or January. This is 2017. I think it's May. All right?
Okay, sir. Thanks.
So here's this now. You're going to take x minus 1 and then x minus 5. This is equal to 0. Watch this now. Either, we're almost there, either x minus 1 is 0 or x minus 5 is 0. X minus 1 is 0. Add 1 to both sides. We're solving. Remember these solutions? Boom. We knew that one long ago. This is the one that we want. Add 5 to both sides. X is equal to 5. Remember now the question said solve the equation to find the other solution. Remember we knew about x equal 1 already when we were proving to them long ago. So we don't care about this now. What we're going to do now is this, okay? What we're about to do right about now is this. We're going to find the other solution. This is the one we need. We need this because remember we have 1, 2 already. We have 1, 2 already. This is already known, all right? So 1, 2 is already known. So we're not focusing on the 1 this time. We're focusing on using the 5. So watch this now. What is y equal to, right? So let me, can I just put it right here? So I'm going to say when, watch me now. I'm going to say when x is equal to 5, put it in the box. Solution time now. When x is equal to 5, what is y? Y is equal to 3 minus x. That was what we had for our third equation right here. So all we're going to do now is substitute. Y is equal to 3 with a minus, put the 5 where the x is now. This is equal to -2. What does that mean? The solution is 5 with a -2 because this is x and this is y. That's the other solution that they're saying you should get for them and you're good to go. I'm waiting. You could talk to me about any question you want to ask right about now. Now is a good time to ask it. All right. So the other solution is 5 -2. Somebody just mark my board if you don't mind. Could you just reverse that for me? I appreciate it. If not, I'm going to have to jump out of my screen and come back. Talk to me now, people. Talk to me. Talk to me. All right, let me jump out of the screen and come back. All right, let me jump and come back. Give me a minute. All right, let me go back. All right. I wanted to get rid of the mark. It's gone. All right, we're good. All right, anybody, we're good? We're good?
Yes, sir.
Are we good?
Yes, sir.
All right.
Excuse
All right,
me,
let's see. Yes, I'm listening to you speak. Speak.
sir. What time does that finish?
Oh, me don't know. We just work until the people in burn up. I don't have a time. All right, we don't have a time. Remember, you're free to do what you have to do. This is extra class I'm doing, so I'm just working until probably people tired. All right?
I know, perhaps.
All right, good. Anybody, where are we now in terms of with? Are we done? Is that this question is finished? All right, let's. Oh, yes, it is. Yes, it is. All right, so we're going to number 7 now. All right, everybody. So you see a typical number 8, not bad. Not bad, not bad. We're at number 7 now. And number 7 is our pattern question, right? Pattern. So let me see this time. Figure 6 dots. Oh, the axe. All right, there is our number 7. Typical number 7 pattern, some form of shape looking thing where you just observe and you keep rolling. Let's get into it. Are you ready? All right, let's go get it. Let's go get it.
Yes,
it says here, it says the first 4 figures of a sequence are shown below. Figure 1 is a single dot. Figure each of the following is consisting of black dots arranged in an equilateral manner. All right, good. Draw figure 5 of the sequence. You have to observe. But what I do want you to focus on, a lot of times they tend to repeat parts of the previous and add to it. So you could look. So I'm just going to highlight a pattern. This is 1 that sits on top. Then we added just 1 more to make 2 for the second. We pull back all of this, which is the second figure, and then we add a layer of 3 for the third. Then you wrote back all of that for the third, then you add a layer for the fourth. You could see the pattern. I'm going to draw back all of this. I'm going to draw back all of this for the fourth, as is. So let me see if we can. Oh, hold on, people. Let me see if we can do something weird. Yes, sir. Got it. All right, so I'm gonna draw back that. Honestly, me just think about this and it work. For real. Like, this is so beautiful. This cute, no? Yeah, man.
Yes, sir.
Really cute, man. Just thought about it and it worked. So that is the fourth one. Now we're going to lay 5 on the yes or no. Not you. 1, 2, 3, 4, 5. Done. And let me minimize my pencil size. And then go back to that and we normal again. That's it, you know? Talk to me now, man.
So
Talk
do
to
they
me.
have to be identical? Like they have
Yes,
to look
sir.
exactly like the picture that they gave to us before?
All right. Could somebody tell me what she said? I didn't hear it clearly.
I'm
Somebody.
asking if they have to be identical to the image above.
All right. May I try understand what we mean by identical? Are you asking? May I try understand what you're asking? Because you're asking me if this shape that you draw must look like this. Is that what you're asking me?
No, I'm asking if they give, this is pretty simple. So I'm asking if they give a different shape otherwise from this, and it's pretty complex to draw if they have to look identical
Oh,
to
me get
what
what
they
you're
give.
saying now. All right. So you're asking a general question to say, what if it is a very difficult diagram to draw if you have to nail it? Is that what you're asking? All right. So I'm going to be real now. This is a question I mark for CXC. I mark number 7 every year. Because like when you mark, they will give you a question. You don't get multiple questions because you're going to mark loads of the same thing over and over. So I mark this question. What we look for here is you need to have the general shape. That general shape. You notice the general shape that we have here have a triangle looking balance thingy. They're looking for the general shape. If you're talking about if this bigger than this and it's smaller, and you know, have to be identical if that's what you're asking. Not really. They're looking for the general shape and build up of the thing. They're marking for that over some other stuff. So if you have the general shape of what you're supposed to get, they're not gonna say this one look a little bit bigger than that. No, they're not focusing on that. But you're gonna try your best to make it look good enough. But no, they're not gonna say, boy, this bigger or so. No. But you try to make it look neat. So like in the exam, to be honest, if I do this, you're good. So if this make you feel better, you just have to do this with a pencil. You feel like you're all right with that, you just have to do that. You good?
Yes, sir.
Yeah, man. From you do this in the exam, you're good. Like when we just do now. This is it. When we mark this, you do this, full marks. See there? This is full marks.
Sir, but if you look at figure 4, if you put the additional 5 beside the 4, you'll still get the figure.
Yeah, man. That's what I'm saying. You draw back this and you add your layer to it. So it's like you have this to look at. So you recreate theirs first, but you still have to recreate it and then you add your layer to it. Not true. Basically, that's what you're doing. And 9 out of 10 times you do that all the time. But the bottom line is she was asking if this size, basically she has to say if she have this, you're good to go. Full marks for it. All right. Normally it's 2 marks though. You're gonna get more than 2 for that. All right. But we want to clean up every single mark. Are we there? Now the question says, how many dots would be the 6? Hello. Now we want to think. No. No, watch this. How many dots will be the 6? That means you can count, you know, look, you can count. Look, pattern 1, 3. How much is this? 6. How much is this? Look what you got. 1, then this is 3, 6. But well, don't even look at it like that. Count these, right? Count these. Hold on. Oh my Lord. Backwards. Oh, I have another one here. Thank you. Count these. So you want to count off this, right? This is 1, then 2. I'm just saying, count. Look, count. 1 plus 2, then 3. Don't crucify yourself. Then 4, then 5. Based on the pattern, what is going to be added next? Come on, somebody, just tell me. Pattern, what's going to be added next? 1 plus 2.
6.
Exactly. Exactly. Which is what we keep doing, because if I'm going for the 6 figure, I will be adding 6 at the bottom. So now let's check this up and somebody tell me what number them get. I call me slow. I don't own a brand.
21.
Exactly. And the answer is definitely 21 dots that we have representing there. 21 dots we have. And it's 1 mark because they're expecting you to just understand that you're adding. So this one is testing to see if you understand that you're actually adding a layer each time to the next one, to the next one. All right, everybody? Good to go? All right. All right, so we could go again. We could go again. Now it is now that they have the nice table that they always have for us, right? So they normally have a table that they want us to complete. So in this table here that we have to complete, it says the table below, guys, where am I going? I'm going about 2 hours already. Tell me one time, you know, because when my back we are going, because remember the other class, we came up to number 7. Oh, we can't stop. That's a 2 hour now. We can't chill because we go back to number 7 now. 7, we can chill after this. Because with the main question, them gone. Tomorrow, then we can go from, can deal with it Thursday. All right, let's do this. You said the table below refers to the figure, add the number of dots in each. Study the pattern shown. So you're going to study the pattern shown. Now, more you look carefully. Look, half is out there for everybody. Everybody half there. You want to notice half is there. Then now, look. A multiplication I go on, and you're always going to have one bracket. But look what I go on for the multiplication. First term, 1 there so. Second term, 2 there so. Third term, 3 there so. 11th term, 11 there so. 12th term, 12 there so. The nth term, n there so. Yeah, man, I say go them little thing that you look out for, right? And then look at this now. I want to look. Hold on. Look what is inside here. For the first term, so look here, this is 1. Same for the first, 2. Same for the second, 3. Same 11. 11 I got the desert too. Everybody see that? And everybody at the back have what? +1. Come on, man. So then, if you're going to start out this one though, that's simple maths, because this one you're going to have half times 11. Not true. Then what next? Times open bracket is same number.
11 plus 1.
Hello. Hello. And then now you need to work it out and give the final over. You're saying you notice the marginal. If you're not pre, look good if you don't work out. Check out, just check them out against it for yourself. Check it out. Check it out. You're gonna realize that they might work out the thing there. So this is a 1, that's a that. So when you work out this, what we get? Work out this. 12 times 11, and then divide it by 2. Work it out. You get 66 right there, so. You have to put your total. When they work out this, then put them total right there, so. Because if you work out this is 4, 4 times 3, 12, half of 12, 6.
That's
3,
correct,
3,
sir.
You see what I go now? Everybody, we good with this? Talk to me now.
Yes, sir.
Yes, sir.
All right, so for the end, no, in the nth row, so all right, let me say this. You do notice that whenever it's not the common difference thing, the pattern is easy because they have to show you what they're doing and you repeat it. This is the easier one. So this is a half times n, and in here you have n again, then plus 1. That's all. We good?
Yes.
Sir, I don't understand how you get the 66 right there.
You work out this. Work it out and put over there. Work it out. Work out in the bracket. You get 12. 12 times 11. 132. Divided by 2, 66.
Okay. Okay.
Work
Okay.
it out.
Okay.
Just work it out. Sounding good? Are you there? All right, so we're good. All right. Over here, so now what you want to do is basically them I say simplify this given a man. This over here, if simplified, basically, it's like you have this. It's like you have n times n plus 1 over 2. Agree? Like when you're simplifying this, you're going to end up with n squared plus n over 2. I'm just saying, can you see it? Are you good with it? Like when you simplified for them. Since this is simplified to come here, and this is simplified to come here, I'm suggesting that you simplify this to go here. Don't just give back this. You have to fill it over. You're going to have to fill out the blank spot, which is a simplified version of that. The 2 is at the bottom and the end side of that, and you can distribute it and then set it up so them can see. N squared plus n over 2, are you good? Tell me if you're good, bro. Or you could just leave it as, listen, even this good to you, man. Same thing. Good to go. All right. But
So
in
I
terms
was
of,
wondering why not that way with the
yeah,
half.
man. Good way, man. You can't put any one of them there. What I'm saying is all of these are accepted. But we see what we don't want over there. We don't want to have the multiplication signs and so on. We don't want you put it together now. If you understand the point I'm making, put it together now. So yeah, man. I mean, think me like this one more than the others. Because you don't want to see the quadratic, yeah? We know people don't want to see the quadratic. Let's go. All right. Complete. It says complete. So you want to complete the row. We done that already. That's what we're doing here. We did this already with 11. Everybody see this? We did that already. All right. Now D, the D part of the question says, determine which figure in the sequence has 210 dots. Dots. Look where the dots are. You remember this pattern thing? This is dot, you know. Dot is over here. Dot is represented by half n. Dot is represented by this. This represents dots. So every time you get a question like this, you have to go look back at the column, see what is represented what. The number of dots used is over here. So I'm saying the number of dots, half n times n plus 1 gives 210. We know that the dot is represented by half n, open bracket, n plus 1. Then we want to solve this, man. Solve ordinarily, right? So you're going to multiply both sides by 2. You're solving it. 2 cancels itself. All right. So you have n. You have n plus 1 equal, what's that? 410. Are you there?
Yes, sir. Yes, sir.
All right. All right. So we have n plus 1 equal that. So what we're going to do now, I just keep working. All right. Keep working. Give me a second. Hold on. Hold on. All right. Good. I'm going to screen me a penny. All right. All right. So for this now, we have to put it together. Basically, we have 2 marks here. This is actually, all right, I'm just going to say something. You're going to say something here. It's a pattern question. You can look. This is actually saying two numbers multiplied by itself. Take a look at it. It's like two numbers multiplied by itself. This is 20 here. Let me write this over. I think let me write it better. This is 420. Now here's the deal. Look, tell me if you'll notice n times n plus 1. Everybody see this? N times n plus 1. What this is saying, two numbers that are consecutive, like 1 and 2, 5 and 6, they multiply to give this. You can find it quickly. You don't have to go through the whole thing to scale up yourself. It's a pattern question. So you can think quickly because this is 400, you know. So you know 20, I'm just saying 20 times 20 is 400, you know. 20 times 20 is 400. You have to think quickly. So this is actually 20 times 21. I'm just saying 20 times 21 give this by looking at it. All right. So they will set it up a way where, because the reason why I'm saying this is like, you know, one go in a quadratic. Because if you distribute this, you're going to get n squared with n. Yes, it can work, and you factorize and find the answer, but I don't want to do that right now. So may I say, when you look at this, you're seeing two consecutive numbers. One is n, and one is n plus 1. That means they're beside each other. Two consecutive numbers. I'm saying it's 20 times 21. Put it in your calculator, 20 times 21. That's that. So what is n? What is n? N is 20, right? What is n? 20. 20 plus 21. 20 times 21 should say is 440 right there. Is 420 right about there. So n is 20. All right, determine which figure. So this is be the 20th. 20th figure would have produced that. That mean if you put the 20 in our words, and if you put 20 in the formula, you say 20 open bracket. Right, that's what we are talking. 20 plus 1. That's 21. When you multiply it, you do your thing, you divide it by 2, you get it. Trust me. So some of the time you think it through quickly. I'd never wanted to go in a quadratic, but the 20 and the 21 would have factorized it, but that takes too much working out for you right there. So you use 20 and 21. All right. So that's for that. Look at the next one now. It says, write a simplified algebraic expression for the number of dots D in the figure N. But we have that already. You notice them say write a simplified. All right. We did this already, right? Well, it look like we did this already. All right, hold on. I'm looking at the questions. Because it says write a simplified algebraic expression for the number of dots D in the figure N. I think we do this right here. Simplified. It's this. The same thing that you have here. We have that already, man. All right, we have the same of N. We have the same of N plus 1. D, look. They're saying to write a D. Like, simplify this. But we had done it long ago. This. Simplified it, we get this long ago. We did that long ago. That's a simplified version. All right. All right. So it says now, show that there is no, all right. Show that there is no 1,000 dots. In other words, if you continue doing what you're doing, you can't get 1,000 dots. You're going to take this same thing here. This represent dots. Remember this, you know, equal 1,000. Yeah, I say, I'm going to do the same maths. I'm going to multiply by 2. Watch. The same thing when we just do. So you have n times n plus 1 give 2,000. In other words, can you find two number or multiply by itself to give 2,000? Two number or multiply by itself to give 2,000. And you realize that you're not going to find that ever. All right, there's no two number that multiply by itself that are consecutive. So the thing is, can you find two consecutive numbers that multiply to give 2,000? you can write a statement and tell them that, no, we can't find two numbers that multiply to give. And you can try to. You can go up close to it if you want and show them, all right. And let me just show you what I mean. 44 times 45 give this, okay? 45 times 46. 45 times 46 give this. Consecutive. Because if 44 times 45 drop below it, and then 45 times 46 go over it, there is none. I'm just saying that to you. This is problem solving investigation, and you explore the idea. The key concept is in this question is to understand that two consecutive numbers multiply to give the dots. And if you can't find it, you could tell them that, hey, two consecutive dots. We can't find two consecutive numbers that multiply to give 2,000. And then you can write that, because you're not seeing, look, we're seeing where this give us that, and these numbers are the numbers that will pass 2,000 and go near to 2,000, right? So you realize that that's the case right there. So we can't find two consecutive numbers, so there is no 1,000. So yes, that's your response right there. Everybody good with that? But at the same time, you would have needed to see the fact that a number multiplied by the next number beside it always produce the dots. That's what is going on. That's what we're noticing. All right, that's what we're noticing there. So we use that idea to fuel the responses. All right, that is actually the end of that one there. All right, we think we'll probably pull it down. That's like a good almost 2.5 hours. All right, very good. So what we're going to do now is we're going to break again. We're coming back Thursday. Same time, basically. All right, so Thursday we're coming back same time. Or we probably can come back later, I'm not sure. Maybe we can start later because we probably will go longer. But I'll tell you what time we're going to come on. I will just go and learn some maths until we're probably tired. Probably do 1 2 hour and chill. So maybe. All right.
Yes.
All right. All right. Take care of yourself. Until then, we're going to close this live.
Thank you, sir.
Yeah, man, we're going to close the live now. So looking forward to see you again. I trust that you guys enjoy what took place. Bye-bye.
Thank you, sir. Bye.
All right. Bye.